We'll now look at how to find the arc length of a curve. The idea is if we have some portion of a curve and we want to actually figure out, if we were to use a string to measure from one end to the other, how long would it be? And this actually comes from a formula, the integral from a to b of the square root of 1 plus f prime of x squared dx. And we'll do a few examples of how to use this formula. We'll start with this example. Y equal to 8 over 3 times x plus 3 to the 3 halves on the interval 0 less than or equal to x less than or equal to 2. The first step in finding any arc length is to take the derivative. So we'll use different notation and actually say y prime. This is 8 over 3. We bring our exponent down and subtract 1. In addition, we need to multiply by the derivative of the inside, but in this case, that's just 1. This gives us 4x plus 3 to the 1/2. The next step is to square this value. If I square, 4 squared is 16, and the square root of x plus 3 squared is x plus 3. Therefore, I have 16x plus 48. And now we're going to integrate from 0 to 2 of the square root of 1 plus this value we just found. Simplifying a little bit gives us that this is the integral of 16x plus 49. We may not immediately be able to do this, however, we could with a simple u substitution. I'm going to let u be equal to 16x plus 49. Therefore, du is equal to 16 dx, which I'm going to rewrite as 1 over 16 du is equal to dx. When we do this, this now becomes the square root of u, which I'll write as u to the 1/2. The dx becomes a 1 over 16 du. We also need to change our bounds. If x was 0, u is 16 times 0 plus 49, which is 49. Once we simplify this, we get that the arc length is 193 over 12. Next, we'll consider this example. Y equal to x squared minus 1/8 ln x, where x is between 1/4 and 1. The first step is to take the derivative. Derivative of x squared is 2x, and the derivative of 1 over 8 ln x would be 1 over 8x, since the derivative of ln x is 1 over x. We're going to rewrite this slightly as 2x times, or minus, 1 over 8 times x to the negative 1. We then need to square this value. That gives us 4x squared. We then multiply 2 times 1/8 to give us 1/4, times 2 is 1/2, and then we square the last. 1 over 64 x to the minus 2. Therefore, we have the integral from 1/4 to 1 of the square root of 1 plus 4x squared minus 1/2 plus 1 over 16x to the negative 2 dx. Well, this doesn't really look like it can simplify a lot. I can combine the 1 and the 1/2. That gives me 4x squared plus 1/2 plus 1 over 16x to the negative 2 dx. But this is actually enough. If we look back over at the left, this was 2x minus 1/8 times x to the negative 1 squared. And we see the only difference between what I had originally and what I have now is that middle term is positive. And so if the middle term is changed, that just changes the sign in my factoring. Therefore, this is the integral from 1/4 to 1 of the square root of 2x plus 1/8 times x to the negative 1 squared. Therefore, my square and my square root cancel each other out. I end up with just the integral of 2x times 1/8 x to the negative 1. If we try to figure this out, we get x squared. In the second term, adding 1 to the exponent would give us 0, so that's not good. But we actually know that the integral of 1/x is ln of x. So this is plus 1/8 ln x between 1/4 and 1. And then once we simplify this, we get 15 plus 2 ln 4 over 16, which in decimal approximation is approximately 1.11.